So this video is to help you understand how to name alkanes. So we're going over the nomenclature of alkanes. So again, I told you that, I don't want to spend too much time in class going over this because I think it's more important that I spend my time on the more difficult concepts like, conformations, chair conformations, ring flips, and stuff like this. These students have a lot more trouble doing. But when it comes to nomenclature, there's a systematic way of naming compounds. So I think you guys can kind of go through and learn the rules and learn the process because it is a step-by-step process. But nonetheless, I'll go ahead and do some guidance here just to try to get you familiar with that process if it helps you. So when it comes to nomenclature, we talked about this part in class. We said that, it's the name of a compound is composed of a prefix, and the prefix tells us what and where are the substituents. And then the parent name tells us what's the longest carbon chain, and then the suffix tells us functional group. So if you have a suffix such as ane, that's an alkane, such as -al, right, that's an alcohol, and so forth. We also reviewed the parent names, right? 1 carbon being methane, 2 carbons ethane, 3 carbons propane, and so forth. We can go past octane, we can go to nonane and decane, and so forth. So you want to make sure that you commit those to memory so that you know the names of those longest carbon chains. So what I'm going to do now is we're going to go through this step by step on how to name molecules, and we're going to start with naming acyclic alkanes. So naming acyclic alkanes. All right, so the first step that you want to keep in mind here is that you want to find the longest continuous carbon chain. So that's the first thing. Find the longest continuous carbon chain. So if I have, and I'm going to delete the hydrogens for now. You would never draw it like this. If you're going to do a Lewis structure, you would include all atoms. So keep that in mind. I'm just doing this for simplicity, so that I can make the point about the longest carbon chain. But you would actually never do this on an exam or an assessment because it would be an incorrect Lewis structure, right? If you did so. So if we look at this here, the longest carbon chain. If we try to find where's the longest continuous carbon chain, then it would be this one that is straight across, right? So you would see that this part right here, let's use this, this is going to be the longest carbon chain, right? So at that point, we would call this molecule octane, right? At least the parent name would be called octane. Okay, now we still have to worry about everything that's coming off of it. These things that are coming off of the carbon chain, these are what we call substituents, right? Those are what we call substituents. They have specific names, and we'll get to that in a minute, but anything that comes off of the carbon chain is what we call a substituent, and we'll get to the specific names in a minute. But the first thing is to find the longest carbon chain. Now, there are some rules to this, right? There are some rules to this. So here's the first what if, right? I should say what if, not rules. There's what if situations. So if 2 chains are equal in length, pick the chain with more substituents. Right? If 2 chains are equal in length, pick the chain with more substituents. So let's say we have a situation such as this. Right? And I have a carbon coming off of here, another carbon coming off of here. Right? So let's say I have that type of situation here. And if you try to find the longest carbon chain, right, there might be 2 different ways to do this, right? One of them is where you go straight across. 1, 2, 3, 4, 5, 6, 7. So that's one possibility. The other one, a longest carbon chain possibility, is that if we go this way, 1, 2, 3, 4, 5, 6, 7, right? So with that said, which one of these is going to be the better choice, right? Which one is going to be the better choice? Is it going to be A or is it going to be B? Which one is going to be the better choice? That's going to show the longest carbon chain with the more substituents. And you would see that it's actually going to be A, right? Because in A, we have 2 substituents, 1, 2, coming off of the long chain. In B, we only have 1, right? So we only have 1 substituent coming off the long chain, right? So one thing branching off. So in this case, the answer is definitely going to be A. A would be the correct answer here, okay? So that's what we mean by that. All right, so now let's go to step 2 here. So step 2, number the atoms in a carbon chain giving the first substituent the lower number. Okay, number the atoms in a carbon chain, giving the lowest substituent the lower number. So if I do this here, right, well, we would find the longest carbon chain would be, again, straight across right here. Here's the longest carbon chain, right? And remember, substituents are anything that are coming off of the longest carbon chain. So there's one here, another one here, and one here. Well, the question is, do I want to number this going this way, right? Do I want to number it going this way? Let me use a different color here. Right, so I'm numbering the longest carbon chain. Or do I want to number it going the other way? 1, 2, 3, 4, 5, 6, 7, 8. So, but I want to make sure that the first substituent has the lowest number. So going the purple numbering, the first substituent's at number 2. Going the blue numbering, the first substituent's at number 3, right? And I want to give it I want to go the route that gives me the lower number. So in this case, the purple numbering is correct, right? So it'd be the purple numbering that would be correct. We would number it this way, okay? So purple wins in this case. All right, so go ahead and erase these just so that we understand, okay? All right, now let's do some what ifs, right? Let's do some what ifs. If the first substituent is the same distance from both ends, number so that the second substituent has the lowest number. So if the first substituent is the same distance from both ends, number so that the second substituent has the lowest number. So if we do that here, here's an example. Right? If I have something like this, the question is, do I want to number it this way? 1, 2, 3, 4, 5, 6. Again, because this is my longest carbon chain right here. right? And here are my substituents. So do I want to number it that way, or do I want to number it going this way? 1, 2, 3, 4, 5, 6. Well, in this case, if I go up the purple, my first lowest number is at 2. If I go to blue, my first lowest number is at 2. My first substituent's at 2. So that's tied. So then what we do is we use the second substituent. Well, in the purple, the second substituent's at 3. In the blue, the second substituent's at 4. So again, purple here is going to win, right? If it's going to tie, right, then you go to the next one and make sure that that one is going to be the lowest number, right? So the purple, in that case, is going to win. All right? Okay. Now, so the next thing we're going to do here is name and number the substituents, right? So the third step here in the process, is to name and number the substituents. All right. So the question is, well, how do I name substituents? Well, let's say that R is the longest carbon chain here, right? So I'm going to put here R. R equals the longest carbon chain. So that's what we've been highlighting in orange, right? So we've always been highlighting the longest carbon chain in orange. All right. So let's say that we have this long carbon chain and there's a CH3 off of that, right? Well, this is basically replaced. If we look at it, that's basically saying, and let's try it this way. If we looked at this molecule here, the name of this molecule is methane, right? The name of this molecule is methane. But let's say that one of those hydrogens is replaced with the longest carbon chain, right? So here we have these hydrogens, but one of them is replaced with the longest carbon chain. That means that this is now a substituent, right? It's coming off of the long carbon chain, and if it's coming off the long carbon chain, all we do is change the ane ending to YL, and this is now going to be called methyl. So the substituent name is called methyl, right? So same thing here. Let's say that I had this here. So this molecule we already know has the name ethane, right? This has the name ethane. But let's say that in this case I replace one of those hydrogens here, right? I replace one of these hydrogens here with the long carbon chain, right? Let's say I replace with one of them with the long carbon chain. Well, now, so remember this was the long carbon chain here. Now this is a substituent. Right, now this is a substituent. So rather than being ethane, we're going to say this is ethyl. Right, this is ethyl. So if it was a propyl group, then you say propyl. If it was a butane group, you say butyl, and so forth. Right, so you just change the ane to YL. Now there are others here that you need to think about, though. So for example, propane. If you had propane here, you can think that you can substitute at different hydrogens, right? If you were to put the R group at the end, that makes sense. If you put the R group at the end here, then this would be propyl. Right? However, if you were to put it in the middle hydrogen, right? So in other words, we do the same thing here. right? But in this case, I'm going to put the longest carbon chain in the middle hydrogen. Then this is now called isopropyl, right? This is called isopropyl. This is called isopropyl here. Okay, and another way to look at it is if you draw out the skeletal structure, right? If you look at the skeletal structure, it's going to look like this. Right? Kind of looks like a peace sign, right? It looks like a peace sign, where this one would look more like that, right? So there are a number of these, right, that you need to be familiar with. And the biggest thing is to commit them to memory, right? Commit them to memory. So if you had something like this, so let's say you have a carbon chain like this, right? This one is called sec-butyl. If you had a chain that looks like this, right? This is called isobutyl. If you have this one, this is called tert-butyl. Looks like a chicken foot. I call it the chicken foot. Right? So you need to be familiar with the names of these substituents. Okay, you need to be familiar with the name of those substituents. So with that said, then when numbering the carbon chains, those result in the same number. Or when you're numbering the carbon chains, you're going to be responsible for being able to name those substituents, right? So if we think about this, I'll give you an example here. So here we go. All right. So if we have something like this, we would try to figure out the best way to number this, right? So in this case, what we would look at, we'd say, okay, well, let's number it straight across. So it'd be 1, 2, 3, 4, 5, 6, 7. So here's the longest carbon chain, right? There's the longest carbon chain right there. And then here are the substituents. So we need to name, so you say, well, why didn't I go the other way, Dr. Elad? Well, if I go the other way here, numbering, we end up 1, 2, 3, 4, 5, 6, 7. So in both cases, the substituents end up at 3 and 5 in both cases. So this is why we need to also be able to name them. Because if we look at the substituents, well, this substituent is only one carbon. So we said that the name of that substituent is methyl. And this name of this substituent is 2 carbons. The name of this substituent is ethyl, right? So this leads us to a what if, right? What if? So here's a what if. If when numbering results the same numbers from both ends, assign the lower number alphabetically, right? alphabetically. In other words, in this case, since we have to figure out, well, who's going to get the 3? Is it going to be methyl or ethyl? Well, it's going to be the one with the ethyl, right? Because E comes before M. So E comes before M, so the actually purple would be correct here, okay? Because E comes before M. All right, so when we name and number the substituents here, this is what we're doing, right? We're saying that at carbon 3, there is an ethyl group. So we say 3-ethyl, and at carbon 5, there's a methyl group, 5-methyl, right? So that's how we're numbering them. Now, let's say, so let's do another what if, right? Let's do another what if. If 2 or more identical substituents bonded to the same, or identical substituents are bonded, use prefixes such as di, tri, and tetra, right? If that is the case. So here's an example of that. Right? So if I'm looking at this, I'm trying to number them, then I would know that I have to use the longest carbon chain, which is right here. And it's not always horizontal, so you want to keep that in mind, right? You need to find the longest one. I'm doing this for simplicity. But we do 1, 2, 3, 4, 5, 6, 7, 8, right? So in this case, I see that there is a methyl group at 2. There is an ethyl group at 5. So this is 2-methyl, 5-ethyl, and then 6-methyl. Well, I have 2 methyl groups, right? So rather than saying 2-methyl, 6-methyl, what I can say is 2,6-dimethyl, right? 2,6-dimethyl. This di suggesting that there are 2. Okay, so that's how you can do that. All right. So now we're at. So this was here we were talking about with step 3, name of the substituents. Now let's go to number 4. Step 4, and that is combine the substituent names and number the parent plus suffix, right? So we're going to combine the substituent names and number plus the parent plus the suffix. So a few things to keep in mind here, right? We want to alphabetize the substituents. Alphabetize the substituents, ignoring all prefixes except iso. So we'll ignore like iso and we'll ignore di and tetra and tri. The only one we do not ignore is iso when we put them in alphabetical order. We're going to name, we're going to separate numbers by commas and separate numbers from letters with hyphens. So we want to keep that in mind. So if we give that a shot here, right? If I look at this, let's try this one. right? Again, find the longest carbon chain. If we look at that, we go straight across. Here's the longest carbon chain. Number them so that the lowest substituent gets the lowest number. There we go. And then name the substituents and their location, right? So we would say, okay, well, this would be 2-methyl. This would be 5-ethyl. And this would be 2-methyl. And now it's time to combine all of them, starting with the substituent names and their numbers, followed by the parent, followed by the suffix. And if you do that, then you would say this is called, and we're going to go alphabetical order. So E comes before M. So it's going to be 5-ethyl, right? 5-ethyl, and then hyphen 2, 6 hyphen, because we separate hyphens, numbers from letters with a hyphen, dimethyl octane, right? 5-ethyl 2,6-dimethyl octane, because octane is the parent name. Okay, so how about this? I'll give you a problem here and you give it a shot. Okay, so I'm going to do skeletal structures now. So here we go. We're going to do some practice. I'll give you a skeletal structure. See if you can figure out what this is. At least the name of it. Okay, so go ahead and pause the video and see if you can answer what is the name of this molecule here. All right, so hopefully you're back now. So if we find the longest carbon chain, hopefully you realize that the longest carbon chain is 7 carbons long. So we have this route right here. Right, we have this route right here. That's 7 carbons long. At that would give us 3 substituents. So actually, let me go back and use the same colors we've been using. So we were using orange to identify that. So that would give us 3 substituents if we went this way. Right, that's 3 substituents there. Alternatively, though, hopefully you caught this. Come on. Alternatively, though, you could have also gone this way. One, two, three, four. That way, right? 1, 2, 3, 4, 5, 6, 7. And if we do that, we end up with 1, 2, 3, 4 substituents, right? So in this case, it'd be the second one that would be preferred because we want the one with the most substituents, right? So we want the one with the most substituents. So the second one would be preferred here. So we're going to stick with that one, with the second one. And now we have to figure out how we're going to number them, right? And you, again, wanting to give the lowest substituent the lowest, the first substituent the lowest number. So that'd be 1, 2, 3, 4, 5, 6, 7. All right. So when we go there, then we need to number and name the substituents. So if we look at carbon 2, there's a methyl group, so this is 2-methyl. If we look at carbon 3, there's a methyl group, 3-methyl. Carbon 4, 4-propyl. Carbon 5, 5-methyl. All right, so we say, okay, well, what's the parent name? The parent name is heptane, so we can go ahead and write that. Heptane is the parent name, right? And now we have to name all the substituents, right? And doing the lowest, alphabetical order, right? So M comes before P, so this would be 2, 3, 5 trimethyl, right? Trimethyl, and then we're not quite done yet. 4 -4 hyphen propyl heptane, right? 2,3,5 trimethyl 4-propyl heptane. So hopefully you got it, right? If you didn't, that's okay. That just means that you need practice, right? That just means you need practice. And there's a whole bunch of practice in your book. So make sure you're doing those end of chapter problems and maximize how you are practicing, okay? Now, so I'm not quite done here though. The next thing I want to talk, we talked about naming acyclic alkanes. Now I want to discuss how to name cycloalkanes. Okay. So naming cycloalkanes. So when it comes to naming cycloalkanes, it's going to be the same type of format here. We're going to do a prefix, but now we're going to add the word cyclo, and then we still have the parent and then the suffix. So if we have a molecule such as this, right? If we have a molecule such as this and we're trying to name it, well, we're going to look at the size of the ring. The size of the ring is going to tell us the parent and suffix here, right? So if we look at this, this is a 6-membered ring, right? 6 carbons here. So the parent name is now going to be cyclohexane because hexane is 6. So the parent name is going to be cyclohexane. Okay, because we're going to start with the ring here. Now, when it comes to the naming of these compounds, right, what we want to do is, again, give the lowest substituent carbon number 1. But you say, well, but this is a ring. How do I determine which one gets 1? I could start either at this substituent over here, right, because here's the longest carbon chain, which was the ring, right, and then I have this substituent and this substituent. How do I determine which one gets number 1? Alphabetical order, right? So this is an ethyl group. This is an ethyl group. This is a methyl group. So we're going to go alphabetical order here. We want to make sure that we give all the substituents the lowest number. So it's best to go 1, 2, 3, 4, 5, 6. That way we give the ethyl group 1 and the methyl group 3. We don't want to go the opposite direction, right? We wouldn't want to go the opposite direction where we did something like this. 1, 2, 3, 4, 5, 6, because then the ethyl group would still be at 1, but then the methyl group would be at 5 instead of 3, and we want to keep those numbers low. Okay, so that's why we would number it in the purple manner here. All right, so put that back for you. All right, so that's how you do this. So then the same rules apply. The name of this molecule, we're going to still do it exactly the same way. We're going to say, okay, alphabetical order, 1-ethyl, 3-methyl, cyclohexane, right? 1-ethyl, 3-methyl, cyclohexane. All right, now let's say that we have something like this though. Let's say that in this case, we have this, right? We said, well, do I use the ring or do I use the longest carbon chain that's acyclic? You find the longest carbon chain. So you have to choose, is the longest carbon chain acyclic or is it the cyclic ring? Well, in this case, the longest carbon chain is this part right here, right? So now we're going to treat the ring as a substituent, right? Because the chain is longer. So we're going to treat that as a substituent. So you said, well, how do I name that? Well, that's cyclobutane, right? So all we're going to do is for the substituent name, nothing changes. It's going to be cyclobutyl, right? Again, because the ring is smaller than the longest carbon chain. So if we think about this, then we would number them also, right? We would say 1, 2, 3, 4, 5, 6. So the name of this molecule would be 1 cyclobutyl, because that's a substituent, hexane, right? 1-cyclobutyl hexane. All right, so let's go ahead and let's try this one here. Go ahead and pause the video and see if you can try this one. Go for it. Pause the video, see if you can determine what the name of that molecule is. All right, so if you did that, then you would say, okay, well, I can see that this is a cyclohexane, right? So because here's the longest carbon chain, and it's the ring, so it's cyclohexane. And then I have these two substituents here, right? Here's one substituent, here's the other. So I need to be able to name these, right? So this one here is, we know this one's methyl. Now this one, we said you had to commit to memory. This is called sec-butyl. So if we put this together, remember we ignore prefixes such as sec, di, all these. The only ones that we don't ignore is iso. That's the only one that we don't ignore. So that would mean B comes before M. So it'd be 1, 2, 3, 4, 5, 6. So if we name this, hopefully you got it, it'd be 1-sec-butyl, right? 1-sec-butyl, 3-methyl cyclohexane. All right, so hopefully you got it. If you didn't get it, don't worry about it. You just need practice. And like I said, there's a lot of practice at the end of your chapter. So make sure that you're practicing, because this is how we speak, right? And when we talk about compounds, this is part of the language that we use. So hopefully you found this video helpful. But like I said, make sure you're practicing here. All right, see you in class.